In this video, we are going to discuss about monostable multivibrator. It is also called as one-shot multivibrator. So, this circuit will produce a single pulse of specified duration in response to each external trigger response. It has a stable state and quasi-stable state. When an external trigger is applied, the output changes the state. So, the new state is called as quasi-stable state. The circuit remains in the state for a fixed interval of time, and then it will return to the original state after this interval. This time interval is determined by charging and discharging of the capacitor. The time duration for the output pulse is achieved by connecting the required component. So, this is a circuit diagram for the monostable multivibrator. So, you can see you have a VT is nothing but I'm going to give a square pulse. Okay, so I'm going to give a square pulse here. So since it is a differentiator circuit, okay, this is a differentiator circuit. So it will produce a pulse signal at the output. Okay, so since I have connected one diode here, okay, since I have connected a diode, so it will passes only the negative signal. So at this point, so you have only a negative pulse. Okay, so this is what you will get at the output. Okay, so let me take this voltage as VR. Okay, so let me assume the initial voltage of the V naught is equal to V saturation. Okay, V saturation, and so let me take since it is V saturation, this capacitance value is very low. So this output will charge this capacitance. Okay, so it will charge the capacitance, but the capacitance value it will not go more than this 0.7 volt, because if the capacitance value if it goes more than 0.7 means this will charge, this will become short circuit, no? So it will not go more than about the 0.7 volt. Okay, so you can see the capacitance voltage, the voltage across the capacitance is 0.7. Okay, 0.7 volt, and my output V naught is at V saturation. Okay, so this is the initial condition. Okay, now I am going to apply the trigger pulse. Okay, so I am going to apply a trigger pulse here. So if I apply the trigger pulse, so this is my VR. Let me assume this is VR. So I am going to apply the trigger pulse only at this point. Okay, so it is of short duration. So since I have applied the trigger pulse, it is of negative value. The minus value, that is V minus, is greater than VR, V plus, right? So if I apply the negative pulse here, so this the capacitance voltage, that is VC here, is 0.7. So and this will goes less than 0.7, right? So what will happen? The capacitance start to discharge. So it will discharge up to. Okay, so now the capacitance start to discharge, right? So the capacitance start to discharge, and it will discharge till the point that is called as beta V set, right? minus beta Vsat. So it will discharge up to minus beta Vsat. So since it is since I am applying the negative trigger pulse and the V minus is greater than V plus, the output goes to V saturation, minus V saturation, right? So it will go to minus V saturation, right? So it will go to minus V saturation. Okay. So once it reaches minus V saturation, okay. So once it reaches this minus V, if it is going less than the minus V saturation means now the V plus value is greater than V minus, right? So if the capacitance voltage, it will goes less than this minus V saturation, what will happen? V plus will be greater than the V minus, right? So at this point, it will go again to plus V saturation, right? And the capacitance start to charge, right? So the capacitance start to charge and it will again reach the value called 0.7 volt. Okay. So which one is the time period? So this is my time period, right? So now I can write what is Vc of t. So Vc of t is equal to, we know that V final plus V initial minus V final e power minus t divided by RC. Okay. So which is the final value, it has to reach minus V saturation, right? So the final value, so this is my initial value and this is my final value. So the final value it about to reach is minus V saturation. So this is my final value, V final, okay, minus V sat. So what is my initial value of the capacitance? So the initial value of capacitance is 0.7. So I can write 0.7 as Vd, okay. So Vd e power minus t divided by RC. So what is the final value it has reached? That is Vc of t value. Vc of t value is this one, right? So I can write this is B minus beta E sat. Okay. So if I solve this one, I can write 1 minus beta V sat is equal to Vd plus V sat e power minus t divided by RC. So now I divide both side by V sat. Okay, if I divide both side on by V sat, I will get Vd by V sat plus 1 into e power minus t divided by RC. So what is my e power minus t divided by RC? That is equal to 1 minus beta divided by 1 plus Vd by V sat. So if I take ln on both sides, I will get t divided by RC is equal to ln of 1 minus beta divided by 1 plus Vd by V sat. So t is equal to RC ln of 1 plus. So since I have minus, the denominator and numerator will change. Okay. So if we know that beta is equal to, what is beta? Beta is equal to R2 divided by R1 plus R2, right? R2 divided by R1 plus R2. So if R1 is equal to R2, then I can write R2 divided by R2 plus R2, that is equal to 0.5. So if you we know that VSAT value is greater than VD, right? So my T is equal to RC ln of, this is 1 plus this becomes 1, right? It becomes 1 and this becomes 0.5. Okay. So if you solve, you will get RC ln of 2, that is equal to 0.693 RC. So this is my T value. So and you have to make sure that the triggering pulse width must be less than the pulse width of the output, right? V naught, that is T. Okay. The applications of the monostable multivibrators, that is used in the time delay circuits. So next it is used in the pulse shaping circuit, frequency division, clock pulse generation, switch debouncing, that is to remove the noise from the mechanical switches. Then it is used in the communication systems and also in the digital logic sequential circuits. So here you can see whenever you have the trigger pulse only, so it will go to minus V sach, then it will reaches the positive V saturation, right? So whenever there is a trigger pulse only, it will go to minus V saturation. Otherwise, it will remains in the V saturation state only.